Hello class, this is Mr. McAllen, and right now I'm going to show you how to do some solutions to solving differential equations. I gave you 6 problems tonight, and here are 3 of them. I'm going to walk you through how to do the solutions. So remember, the most important key steps to get maximum points are to first separate, second integrate, third remember to put plus c for the constant, fourth solve for the constant, and fifth solve the equation. I'm going to do this pretty quickly just to make sure that this is for review and this is not for the first time you've ever seen this. So hopefully you've had a chance to try this out. So in the first problem, we're going to separate variables. So we're going to have cross multiply the y cubed over to the numerator of the other side and the dx to the numerator of the right side. So we separated. Now we're going to integrate. I'm going to pause the video and I want you to try doing it on your own. And when I come back, you're going to see what the solution to this part of it is. So hopefully you got this solution. You include the plus c, and then you've gotten 2 points for the integration and 1 point for the constant. Now we're going to solve for the initial condition. So when x equals 3, y equals 2. So we'll put in 2 to the 4th over 4 equals 7 times 3 to the 3rd over 3 plus the constant. I'm going to pause it again. Why don't you pause the video right now and finish solving for the constant. So hopefully you found the constant to be negative 59. And now I'm going to use that constant to solve for the final equation. So I go back to y to the 4th over 4 equals 7x cubed over 3 plus the constant I just found, which was negative 59. And I'm going to solve for y. So y to the 4th equals, that'd be 28 over 3 x cubed minus 4 times 59 is going to be 4 less than 240. So this would be negative 236. And now y would equal the 4th root of that term. I should always check at the end to make sure my initial condition works. So remember, when x was equal to 3, y was equal to 2. So let's try that out. And I'm going to just check it. Well, you should check it also. I'm going to pause the video and you guys check out that constant. Okay, so when we plug in 28 times, when we plug in the 3, we end up getting a quantity of 252 minus 236, which amounts to the 4th root of 16, which happens to be equal to 2. So my initial condition did in fact check out. Now, what I want you to do is I want you to now look at the next one and separate the variables while I pause it. And I want to see what your answer is to this one. Variables have been separated. Now it's time to integrate. Once we integrate, we want to now solve for the initial condition. This means when x equals 0, y equals 6. In this case, c turns out to be 18. And now we plug it back into the original equation. Y squared over 2 equals 5x cubed over 3 plus 18. Now the rest of the problem is spent trying to solve for y. So I'm going to pause the video again. And when you come back, you should solve for y. Okay, so we're back, and when you make the solution, notice that you have two possible solutions, a plus or minus solution. So you want to always make sure that you choose the right one. That gives us the initial condition that they originally gave us. So when you plug 0 in, we should get 6. So when you plug 0 in for x, you'll get the square root of 36, which we know is 6. So you have to make sure that you use the positive root. So the final function would be y equals the positive root of 10x cubed over 3 plus 36. On the third differential equation, we try to separate variables, but it looks as if they gave us one that might be inseparable. When you get one that looks like this, notice the denominator has a common factor in it, and that would be y. So let's try just factoring out, doing a little bit of cleanup work here when we factor out the denominator. So I'm going to factor the y out, and I get 1 plus x squared. And then this now makes the equation separable because I can cross multiply the y to the numerator on the left side. And you cross multiply the dx to the numerator on the right side. And now you can begin integrating. As a result, the integral on the right and the left are both pretty easy integrals, as long as you remember your antiderivative properties. And now we have to just use our initial condition to help solve for the constant, which is when y equals 0, y of 0 equals 2. So we plug in a 2 wherever we see a y, and we do the inverse tangent of 0, which is also 0. So our constant is equal to 2. We plug that back into the original equation, and we solve. And now to solve for y, we simply cross multiply 2 inverse tan of x plus 4 and take the square root. And remember, whenever you take the square root, to get rid of something squared, you have to include plus or minus. Remember, you have to verify which one of your conditions you want to use. In this case, if we plug 0 in for x, we'll find out that we're again using the positive part of the rooted function. Now we look at our next differential equation, and this will be the last one that we do tonight. The last two you're going to have to do on your own. So we separate variables. I can't seem to get the ink to work, so let me pause the video for a second. It's not pausing, so I don't know what's happening with my stylus. So let me just pause and let me see if I get things working again. Okay, I think things are working again, and hopefully long enough to finish this equation. So we separate variables, y squared dy equals e to the x dx. Integrate. And the left side is pretty easy to integrate. The right side is even easier. And now we solve for the constant. So when you plug in 0 for x, we get 1 for y. Now this is an example here where we don't want to just assume this is equal to 0. Either 0 is equal to 1. So c plus 1 is equal to 1/3. That would make c equal to negative 2/3. And we would plug that into our original equation. And then we multiply both sides by 3. So we have y cubed equals e to the x, 3e to the x minus 2, and y equals the cube root. In this case, with a cube root, there's no plus or minus. So hopefully you found this helpful to solving differential equations. We've seen quite a few, and we'll be doing some more videos to help you understand how to solve differential equations later in the year. But hopefully this has helped jumpstart your mind as far as what you should be doing when you solve differential equations.